Hi guys, welcome. This is the part 2 MongoDB and clean architecture, and in the first part we talked about the clean architecture concepts. So if you haven't visited that part, you can visit that part, which will be in the description of the YouTube video. And so in this project we'll create an ASP.NET 6 Web API microservice using clean architecture, MongoDB connection string, configuration, repository and settings, and running MongoDB database and Mongo Express, which is a MongoDB GUI graphical user interface from a Docker container using Docker Compose tool. And we'll create Web API to perform CRUD operations, install Swagger, which is an open API specification ASP.NET Core app, and run the project and extensively test through Swagger, Mongo Express, and interactive MongoDB shell, confirming the results are in sync across these tools. This is a drone pizza delivery application in microservices architecture, and this tutorial series is built around a blog by Yogesh Adhikari and available at this URL. Okay, so in this tutorial series, we'll be building a complete drone pizza delivery application in microservices architecture, and there will be a total of 2 microservices. The first one will be the command center microservice, which will take the pizza order. The second microservice will be the process center, which will manage the delivery of pizzas through drones. All right. So the original project was built in ASP.NET 5, which I have modified to work on the ASP.NET 6, which is the current long-term service support version. Okay. And there are some changes to the original article, which I have mentioned were relevant, and I will walk you through those changes as well and through the entire coding. And the GitHub code is here, which will also be available in the description of the video. All right, so let's get going. So here in this video, I don't intend to use this as a microservices introduction or concepts tutorial. So if you wish to have some more knowledge about microservices, or if you are coming new to this microservices phenomena, please go through my playlist on my channel, which is here, which I can put in the descriptions. And I've got a series of microservices tutorials, like it is the introduction, created data-driven microservice with API gateway, introduction to command query responsibility segregation. So this is already a 6-part series already available here. So without any further ado, we shall start our journey to create the first of the microservices in ASP.NET 6 and Visual Studio 2022 by opening the Visual Studio. All right, so here I will add a new project. So I already have my recent project templates as ASP.NET Core Web API, and then click on Next, and then I will name it as Command Center. Next, when this additional information screen appears, let me tell you, I am using an existing solution, web application one, rather than creating another one, and I have going to create .NET 6 long-term support, authentication type none, configure for HTTPS, and enable open API support for Swagger, which is just like a Postman is a client, and use controllers. Okay, and click on create, and the command center web API is created for me. So if I look into double clicking this project file, you can see here the target framework is .NET 6, and one of the packages that has been automatically included is swashbuckle.ASP.NET Core, which is swashbuckle is actually it is including the Swagger, which is a client testing the web API. Next, I'll be creating a new folder called entity on the root of the project. So right click command center, add new folder, name this entity, and I will create a order model class. This is my order class, and I will start writing code. This derives or it implements an IEntity interface, which is not there. That's why this is. So these are the 4 properties that I have written for this order class. So this class derives from the IEntity interface. So next create another class IEntity.cs inside the entity folder. So accordingly, I will now create the IEntity class. Next, we add a class called IRepository inside the same entity folder. So the IRepository class is a generic interface, a class that needs to implement. The class which needs to implement the IRepository must also implement IEntity interface, and that is this dependence on IEntity. It is a public interface IRepository T, where T derives from which T implements the IEntity. Okay, that is what it is. The IRepository interface contains methods for performing CRUD operations over MongoDB database. The use of func delegate is for filtering of records from the database. For example, expression funct bool filter means we can provide a function that accepts a T type of parameter, where T is the entity type, T type of parameter, and returns a bool value. We already know that T is of IEntity type. Okay. We now create a new folder called infrastructure on the root folder of the project, and we'll create a new class called DTO. So what we will do is right click, add new folder, infrastructure. DTOs. Okay. Now instead of this public class DTOs, so this DTO.cs, we'll get rid of this part, and this will be a series of records, so record order DTO, and there will be a create order DTO, and there will be an update order DTO. So let's start writing. Pass data between layers and doesn't contain any business logic. I'll be using the web API shortly. I have used record type for the DTOs instead of class, as they are faster to work with and their value cannot be changed later on. So next to the same infrastructure folder, we'll add a new class called extensions.cs. And in this class extensions, we'll create an extension method for the order type, and this will be used to convert order type value to order DTO type. Remember, order DTO is a DTO we previously defined. We will make this class as a static class, so this doesn't require an instance to use it. Okay, so this is public static class extensions, and the code will be so this static method as DTO, it returns a new order DTO, and it takes an order object. Now I will configure MongoDB settings so that the ASP.NET Core application can connect to it and also perform CRUD operations. So accordingly, what we'll do, we'll open the appsettings.json file and modify this. So this part is already there, so we'll keep it as such, and then put another section, rather two sections. Order. The MongoDB settings specifies the host and port of the MongoDB database, and these will be used to create the connection string in order to connect to the MongoDB database. Next, it's time to create the necessary classes for these MongoDB values defined in this file appsettings.json. So we'll create a new folder setting on the root of the project and create two classes. One is MongoDB settings and another is ServiceSettings.cs. Let's now write the code for the MongoDB settings class. And the code for the service settings is So what is the meaning of this init accessor instead of set, which we are used to? So in C# 9 and later, the init keyword defines an accessor method in a property or indexer. And init only setter assigns a value to the property or indexer element only during object construction. This enforces immutability so that once the object is initialized, it cannot be changed again. That means it gives you an immutable set accessor. So you can see there is the following example defines both a get and an init accessor for a property named year of birth. It uses a private field named year of birth to back the property value. Okay, so the init accessor consists of a single statement that assigns a value as it did in the previous example. Okay, so note that because of the init, the following will not work. So here is suppose a person John, var John equals new person, init example. So year of birth is set to 1984. It cannot be changed to another value. So that is the meaning of the init accessor. Now it's time to create a repository which will directly communicate with the MongoDB database. So we'll create a new folder called MongoDB on the root of the project and add a new class MongoRepository.cs to it. The class inherits from IRepository T class. So accordingly, we'll create add new folder and call it MongoDB. To this folder we'll add a class Mongo Repository and click on add, and let's start coding for the Mongo. So now we'll have to install a package called MongoDB.driver. Okay, so let me click find and install the latest version. So it is finding and installing the latest MongoDB driver. Okay, so it does it automatically for you. This Visual Studio has become so powerful. If you forget to install a driver or some NuGet package, it automatically does it for you by prompting you for doing the same. So let's continue coding. Repository, I have to actually implement all the interface members. That's why this squiggly sign. All right, so let's carry on. take a look into this class code. It has method for performing CRUD operations. Okay, all these methods are actually implementing this IRepository interface, where T belongs to T is implementing IEntity interface in its turn. Now I will create extension methods for iService collection type. I will then call these extension methods from the startup class. These methods will create singleton objects for Mongo repository T type and provide it with necessary MongoDB database configurations. Okay, so next we'll create extension.cs class to the same MongoDB folder with the code that I'm going to write. Okay, so extension add class extensions.cs. So public class extensions, actually I will make it static. Now there are two methods in this file, add singleton, where I am fetching the MongoDB values from the appsettings.json file that is in the first of these two methods, services.addSingleton within this add Mongo, and adding a singleton service that will contain these values. Okay, so configuration, this is getting the configuration, and I'm getting the service settings over here, configuration.get section name of service settings.get service settings, and here I am getting the MongoDB settings from the app settings file. These two sections I am getting, and I am creating a Mongo client which is acting on the MongoDB settings and calling the connection string, and it is returning the database with the get database methods by supplying these arguments service settings and service name and returning the services. So this is creating the Mongo database values. And add Mongo repository, this method here I will be providing through dependency injection a singleton object of Mongo repository T whenever IRepository T object is required. Now we will need to register these services, these methods, these two methods, add Mongo and add Mongo repository in the startup class. So we'll add the highlighted code given in the configure services method. But because this is ASP.NET 6, so I'll be using it only through the program.cs file. Now we will need to register these methods in the startup class. However, as you know, there's only one program class and startup class is merged, sort of merged in program class. So I will write the necessary code in the program class and you can follow me. So let's see the program class. So first of all, above the var builder, the first line of code in the program file, I'll have to bring in three libraries, three using statements. So using command center.entity, that's it. So that's the program class where I have added these services, add Mongo and add Mongo repository with order being the entity and named it pizzaItems. And I've also changed this builder.services.add swaggergen. This was already add swaggergen was there, but I have to add a few things by lambda expression where C is the lambda operator, you can say. So this c.swagger version 1 and open API info, and then create an instance of new open API info with the title as command center and the version as v1. All right. The next step in this whole project is running the MongoDB database from the Docker container. So remember, the title of this video is ASP.NET 6 Microservice with MongoDB. So MongoDB will now cover. We have already made the infrastructure in our command center project so that now MongoDB can fit in. But this time I have decided to work with MongoDB as a Docker containers, because Docker containers are widely used in microservices architecture and they are containerized application, and they can be used to run certain components of the microservice. And as you know, for those who have got some previous background or some previous working knowledge of Docker containers, they are very versatile these days. And they, once you have Windows desktop for Windows Docker's desktop installed, then you can get any platform or any even the SQL Server database or any other database such as MongoDB can be containerized, can run outside a local container, and you can use straight away use the MongoDB without doing any expensive setup or configuration or any complication regarding the setting up will be totally avoided. So the default port of MongoDB running on the Docker container is 27017, that is 27017. So I have already specified this value in the appsettings.json file. So if you look into the appsettings.json file, let me see. So this is my appsettings.json. So I have indicated the MongoDB settings host should be our localhost, and port is 27017. So just as I said, we need to have Docker Desktop installed on our machine, and we can download it from this site. So this is a prerequisite for this course, that you have Docker Desktop for Windows installed and running. So if you are working on Windows, you can download it from here by clicking the download link, and it will start downloading. Okay, and otherwise, if you wish to work, if you are having a system Linux, you can click here to install, to download the Docker Desktop for Linux, and then run the wizard to install it on your Linux environment. Similarly with Mac, with AppleChip. Okay, so enough of this Docker Desktop introduction. So we'll be now, I will show Docker Desktop is running on my machine, and I can sign it, but it is not required actually. I have registered to Docker Desktop, and I can now run my Docker containers. So from a previous try, I already have these two containers running, Mongo Express and Mongo. So what I can do, I can just delete them, delete forever, and show it to you afresh. Okay, so this is now clean slate. Okay, so just let me minimize it, and then what I will do is I will have to create a YAML file which contains the MongoDB Docker container name, image, port number, and volumes. Okay, so I will start coding. You can code with me. So as I just said, on the root of this project, right click, add new item, so it's loading the template. Let me search for YAML templates. So I don't get it. YAML. Okay, yes, YAML file. So I will rename this YAML file as docker-compose Docker Compose. Okay, so YAML extension would be automatically fixed. So this is my, it is creating that YAML file for me, empty YAML file it will be. So it has created the docker-compose.yml. Okay, it could be either YAML or YML, it's all the same thing. So let's start coding. So first line of code is the version. So I am using a version 3.8. So how do I know what version I should use for Docker Compose? That is 3.8. So I have found this out from this article. So this is Docker documentation, and you see here there is a compose specification. Choose compose file format is 3.8 is the latest, and that is for Docker engine release of 19.03.0 plus 19.03 onwards. Now how do I know the Docker version? Okay, so for that, this is the command I have given on my command prompt, Windows command prompt, docker / or docker -- version. Docker version is 2010-17. So that's how I come to the conclusion that I should use the latest version, that is 3.8. Okay, so let's start writing the rest of the Docker file. After clearing that error, again click on command line, developer command prompt, and let me get to this side of the screen, and then cd to go to the previous directory, to the final directory, and then cd to the project directory, which is command center. And then issue this command, if I'm lucky this time, it should be all right. Yeah, now it is happening. Okay, so Docker container is being created. The network command center default created, container Mongo started, container Mongo Express started. So it's all done in a jiffy. So you can just verify the creation of these two containers in the Docker desktop. So here you can see that I have brought this Docker desktop which was already running. So I've got these two containers, Mongo Express running as well as Mongo. So let me try and explain to you what is the story behind this Docker Compose. So here you can see this, within the services you have got this Mongo. So within the Mongo this hierarchy and within services, I've already discussed beforehand the version, how the version came 3.8, and within this Mongo I have got this image. And what is an image? Docker image is a file used to execute code in a Docker container. It's a read-only template that contains a set of instructions for creating a container that can run on the Docker platform. Okay, so it provides a convenient way to package up applications and pre-configured server environments which you can use for your own private use or share publicly with other Docker users. Having said that, so as you know, the container is an instance of an image. So it is I have given the name Mongo. It could be any other name, Mongo Demo, Mongo Try, MongoDB or something like that. So this is basically, this part of the YAML file is configuring the Mongo database. And this ports is, the first part is the host port. The port on your local machine is 27017, and this is the container port on the container. And this volumes is optional. It's used to preserve database after the container is deleted. So the source is on my host machine. It is at Mongo Docker data, and target is the target container file path /data/db. This is just optional. You can get rid of this volumes element completely. So let me tell you where it is on my machine. See, this is the Mongo Docker data, which is this file that I have just shown you. Mongo Docker data. Now this path is on my command center, on my root of the project folder, command center. Okay, so it is automatically created when you run a Docker YAML file like this, right? And the Mongo Express is a nice GUI, and it is also running out of the container because I didn't find any Mongo Express GUI as a extension or a NuGet package. So I found from research that I could actually create a container from the Mongo Express image straight out of the Docker Hub. And this looks like it is a web-based guy, and it runs on the port 8081. So 8081 means if you browse to, when it is running, if you browse to http://localhost //localhost:8081, you will get a nice GUI like this. So this is the Mongo Express running for me. At the moment you can see that there are three default databases: admin, config, local, and you can create database manually, but I intend to create it by creating the CRUD application, which will be the next step, by creating an order controller. And when I execute the order controller and browse to the order API, then it will create a database, order database, with a collection called as pizzaItems. Okay, so then let's go for creating the order controller. Two things I need to mention about which are important. Now this pizzaItems is coming from this here program.cs, where we have added the add Mongo repository, and this is the order collection. This is the order database that we are going to create depending upon the order model class, and this is the pizzaItems will be the, you'll see that this will be the MongoDB collections on the order database. Now another thing is that in the beginning, if you remember, I have mentioned that I have made some subtle changes I had to from the blog that I am following on Yogesh Adhikari. So he had actually mentioned about a tool, MongoDB tools, by clicking on the extensions and manage extensions. but here I cannot find any MongoDB tools, and the one that I found from Visual Studio Marketplace does not fit into ASP.NET 6. So I had to find my own solution. So that's how I stumbled upon this Mongo Express, which is a nice containerized tool, and it is easy to use, as we'll see. So let's go now to creating the order controller. So to create the order controller, I will right click on the controllers folder, MVC controller empty, because I'm going to write my own code, right? So order controller is created, which is implementing the base controller class. Okay. Here I have to use a few using statements, bring in some libraries. So I will just start coding, and I'll be silent during the coding process. You can just follow along or stop the recording at places as it suits you, or see the final GitHub repository, which I will show in the description. Okay, so let's go through it. few things to note here in this order controller is the order controller is actually an API controller, since there is API controller attribute applied to it. Next, there is a route order attribute applied, which will call this controller from the URL https://localhost : whatever be the launch URL. That is the port number. So /order. The controller receives IRepository order, okay, object in its constructor by dependency injection. In fact, if you recall, we already defined this injection will be of a Mongo repository of T object in singleton mode. So we'll have to see add Mongo repository T method in the extension class at the MongoDB folder. So if you look into extensions in the MongoDB folder, okay. So there are two methods in this file. This is extension.cs. Okay, so the first method is add Mongo and the other method is add Mongo repository. So in the add Mongo method, here we are fetching the MongoDB values from the appsettings.json file and adding a singleton service that will contain these values, and we are also serializing the git and datetime values with pison serializer class. Like we are registering the serializer with the bison serializer and sending the GUID serializer bison type.string. And similarly, we are actually creating a new object of the type datetime offset serializer of bison type, and then we are calling the appsetting.json with this within this add singleton method. So configuration, we are getting the service for the I configuration, which is getting basically the your appsettings.json class, and then this variable is fetching the service setting, and this is fetching the MongoDB settings, and then creating a MongoDB client. So if you look into this appsettings.json once again, so these are the two settings, service settings and MongoDB settings, which are being fetched over in this file entity.cs and extension.cs, and they are setting to different variables. Alright, and with the Mongo repository, this add Mongo repository, here we will be providing through dependency injection a singleton object of Mongo repository. Okay, Mongo repository of T, generic T, where whenever IRepository T object is requested. So whenever repository T is requested, a singleton object of Mongo repository T is provided. Okay, because Mongo repository T, if you look into this class again, if you look into the definition, so it is again to recall Mongo repository of T, where T is the I. Whenever IRepository is required to be returned, you can return a Mongo repository, okay, with the database and collection name. The controller has web API methods to handle the HTTP GET, HTTP POST, HTTP PUT, and HTTP DELETE types of request. So all of these methods are here in this order controller. Get async, so this is the list of all the items, and this is the get by ID. By supplying the GUID ID as the parameter, you'll get a single object, single order with the ID. Okay, and post async is creating a new order, okay, and it returns created action. This is a special method. It creates a created action result object that produces a status code 201 created response. It creates status code 201. If we look into the Swagger, as we'll see. Now put async method is actually for HTTP put is for updating, and finally the delete async. The controller has web API methods to HTTP get, HTTP post, HTTP put, and HTTP delete type of request. In order to test this method, we'll need to install Swagger, which we have already installed in our project. If you recall, this is a program.cs where you have done all the necessary plumbing to add the Swagger. So services.add Swagger gen. So this we have already discussed, and then we have already put the Swagger as service collection over here, but in this is the part where we are using corresponding to the other earlier versions of ASP.NET Core startup class. So we are configuring the middleware. So here app.useSwagger UI, we'll change it a bit to use the lambda expression C, lambda operator C goes to Now I have run my project, and when the project returns the endpoint, I've got this localhost colon 7196, that is the port number, swagger / index.html, and this port number is assigned in this part of the launch settings.json. So launch URL Swagger is launched at https localhost port 7196. Okay, so that's how it is. Now I'll have to create an order. So for creating an order, let's see the code. Okay, so if you go to the order controller again, and this is the post, HTTP post. The post async method creates a new order in the MongoDB database. It receives a create order DTO record type in its parameter and returns create at action method. So create at action method with the created order and its location URI. So in the Swagger page, what we'll do, we'll click post, okay, and then click on try it out button, and it is giving me the template of a request body, address and quantity it takes. So let's see, the address is just a fictitious address, 123 ABC Street, and quantity could be anything, say 23, arbitrary, and click on execute. Voila, I've got this response body 201 and status code 200 success. Okay, so this is already stored as this is the response. It is an object of the address type is created. Okay, an object of order type or order entity is created. Now let's inspect our MongoDB from Mongo Express to see if it is really the case. See, I have just refreshed it, and you can see, voila, I have got this order. This is the database automatically created through the running the order controller to the order API endpoint. Okay, so let's see what is the collection. So you have this collection data size collection 1, data size 144 bytes. Okay, let's see, and all these details are there. Average object size, objects, index is 1, view. Let's view the collection. See, address 123 ABC Street, quantity 23, and created date is all given. All right. Now, if you look into this get items on this Swagger UI, if you click on get order, and if you click on try it out and then execute, you'll see this order. Okay, it's already there, 200 success. Okay, 123 ABC Street. Now let's create a couple of other post request, create another couple of orders. So post order, I'll try it out with some other. Let's refresh it. Post. Okay, now click on try it out again. This time I give it a different address, say 45 Willaston Place. Flatbush. Okay, and quantity is 67. Click on execute. Okay, and then again this is 201 undocumented response body. 201 is already executed, and this is success, 200 success code. So this 201 is this is created success status response code. It indicates that the request has succeeded and has led to the creation of a resource. Okay, now let's get these two orders, execute. Now I've got these two orders. Okay, now I can see. Okay, again let's see, let's view the Mongo Express here. If you refresh it, now see there are two collections. In this pizzaItems collection, these are two documents. Another address 45 Willaston Place, Flatbush, and quantity 67. Okay, now let's do something else. I have already shown you get all orders. Okay, because these are the two orders that we have created, which have been fetched successfully, and now I will try to get order by ID. Okay, so let's note one of these IDs. Just copy one of these and then get order by ID. Try it out. Okay, so let's get this ID, and it should not this one, sorry, this is one of those templates. So this is the actual ID. I just copy this and paste it here. Click on execute, and it brings me the result. Address, this address, and this quantity 67. All right, so we got all orders. We have been able to post create the orders. We have been able to get all orders. We've been able to get order by an IT. Now let's update an order. So for update, there's put verb. So try it out. Okay, so let's see one of the addresses. So instead of 123 ABC Street, so first of all I put the ID. Okay, let's see the ID. Let's copy the ID. So I have copied the ID, paste it here. Okay, and then instead of 123 ABC Street as it is here, let us see 456 DEF Street. Okay, and quantity is quantities, it was 67, let it be 67. Okay, let's see. Let's not change the quantity and let's see what happens. It is 7B. Okay, so in the ID it was last digit was missing, so let's execute this. So now it should be okay. Is there no validation errors? So now if I click on execute, you can see this is 456 DEF Street and quantity is 0. It was because it was by default 0 and I didn't change it. Okay, so that's fine. Everything is working except the delete one. So let's delete one of those. Let's delete this order, last one. So click on try it out and then click on execute. So this is okay, 200 success, and let us get all the orders, execute. Now one of them has gone and removed. Okay, great. Now what I want to do is to create a few records, created a few orders which I've already created. You can see I've fetched them, and let me test this extensively, this Mongo Express which is running on the Docker container. So if you hit the refresh button and you can see all of these records, you can see what is the record equivalent. It's a documents, they have been added. So this is address, quantity, and created date. Okay, so this is in sync with all these get addresses. Now let's test get with a certain ID and test it on the this Mongo Express. Okay, so I want to fully test it, and then just I will like to show you before concluding this lecture with how to test the MongoDB running of a container interactively on a command prompt. Okay, that also will be the last item. So let's try to fetch an order with a particular ID. So I'll just copy this, and then first of all get by ID. So where it was, post get by ID. So my ID will be try it out. First try it out, otherwise you are unable to work on it. It is disabled. So this is my ID, and if I want to fetch its collection, now this is again a success response, 200 456 Teasdale Street. Now if I click into this pizzaItems collection on this Mongo Express and refresh, or I can just key how do I test it? I'll just come back to you. So now we are testing get by ID for this pizzaItems collection. So what I did is that I fetched the order with this ID starting from EB8 1A9070 and so and so, and I got this address 456 Teasdale Street, Christchurch, quantity this, and created it this. So what I did is that this is key value pair, so key is underscore ID and this value is this, and then I got the same result. Okay, now if you want to test another one, you can try again, execute, and you can see any other. So let's try this one. there should be no typo. Now here ID field, it will be replaced. This the key is ID underscore ID as it is suggesting me. So, and this is type string and find. So this time this is 23 clear. So like I said just a while ago and at the beginning of this lecture, this tutorial, that I will be also showing you the Docker container for the MongoDB running in an interactive shell. So we'll have two things, one is this GUI for the MongoDB that is amply illustrated by me earlier, that Mongo Express. Now it is the turn of interactive mode. So just for our learning sake, so docker exec command with interactive mode IT, and this is the Mongo, this is the container name Mongo, and this is Mongo shell command. So it opens up the shell for you. You can go through this and it comes to this test mode. Now in the test mode, if I wish to see all the DBs, so the commands are so now I have to switch over to order database. So the command is so it shows all the pizza item documents, pizza items collection document. So it finds the item, one item by this ID. Now I have put the MongoDB shell as well as the Mongo Express Docker container side by side just to compare. And now I would like to remove this one, which I can remove from here itself straight away, but I would like to remove it from the command shell just to demonstrate the command shell. So now if I have deleted this one with this ID, so this one should be deleted. So if I refresh, it has deleted that one. And now let me delete this one too from here, delete, and then we'll see the Swagger. And before that we'll check the database from this command shell. So I've got these three results which are the same as here, and then I will just reconfirm these results with the Swagger, okay, to see everything is all right, or Swagger is in agreement with the other two tools for MongoDB. So I brought up the Swagger by running the application, and the Swagger is also in agreement. It has also got only these 3 records. All right. And if I just remove one of these records, say one of these records with the ID, this one, from Swagger, the other 2 should be in sync. So let's see it as the last thing. Let me copy this ID. And delete it from here. Try it out. Execute. So response 200 success. And if I get this once more, execute. So I got these 2 results. All right. And then if I go back to the other 2 tools, here and refresh this, so only these 2 items are there. And even this one also, if I look for db.items.pizza, so 2 items. So that marks the end of all this extensive and thorough testing, and we'll go for the conclusion next. So in this whole project, whole long tutorial, we have successfully created our first ASP.NET Core microservices, which performs Web API CRUD operations on a MongoDB database. And in the next part, I would like to create our second microservice and perform communication with the first microservice, that is this command center microservice. Thank you very much. If you like my videos, please subscribe to my channel, share it with friends, and put your valuable comments.